next topic is our superposition principle and some problems related to that principle. So this principle says that basically it is also related to Coulomb's law. In Coulomb's law we have seen that the interaction between the two charges, that is Q1 and Q2, which are r meter apart, so the force between them is proportional to Q1 Q2 upon r square. So that was Coulomb's law, where constant of proportionality was being replaced. So that was replaced by K, and the value of K comes out to be 1 by 4 pi epsilon naught. Now next we will see that there are a lot of number of charges which are going to be there around this charge. Let us say this Q1, Q2, let us say it is not Q0, it is Q0, Q2, Q3, Q4 and so on up to Qn charges are there. And we have to study how much force they are going to apply over here. So let us say one first charge is applying over the force on Q0. So that means we call it as F1 naught, that is K Q1 Q0 upon R1 naught square. So that is, let us say R1 naught is the distance between these two charges. Now let us say second will be that will be 2 on this one, that is R2 naught. So that will be equal to F2 naught will be equal to K Q2 Q naught upon R2 naught square. Similarly up to so on, if Fno is there, so that will be K Q1 Qn Q naught upon Rno whole square. So this was all about the Coulomb's law, and if you take in the vector form, it will be r vector upon r cube. So r vector upon r cube and r vector upon r cube. That means r1 0 vector, r2 0 vector, rn 0 vector upon r cube. That is in the vector form. So now we will say what is the effect of all these charges, what is the effect of all these forces at this point. So what this principle says, that the net force will be equal to sum of all F1 0 vector plus F2 0 vector plus so on plus Fn 0 vector. So that means sum due to the net force will be equal to sum of the forces due to the all charges. So that is a principle given by superposition. So this principle will be helpful for solving us a lot of problems in the numerical part. Now consider a metal problem. A charged metallic sphere A is separated by a nylon thread. Another charged metallic conductor sphere B is constructed by insulating body is brought closer to A, and the distance between them is 10 centimeter. So there are two charges are there. One is this one placed at this, second is this one. It is brought here up to a distance of 10 centimeter. Both are being charged, positively charged. Now sphere A and B are touched by the uncharged C and D. Now we are going to take two another uncharged conductors C and D. They are being touched with this one, and then C or B are then removed, and then B is brought closer to A by 5 centimeter, between the 5 centimeter. So this one is A and this one is C, then this one is B and this one is D. So both A and C and B and D, they are being contact with each other, although there was a distance between 10 centimeter was being there. So this is uncharged and another is uncharged. Since both of the conductors are uncharged, when they brought in the charged conductors, what happens, the net charge will be equal to, so let us say Q is the charge over here, Q is the charge over here. So according to this charge theory, we see when a very uncharged conductor is brought near a charged conductor, so uncharged, so whatever uncharged means 0, so the charge when they are in touch with each other, according to the principle of conduction, the charge between them will be shared by them. So that means Q plus 0 by 2 and Q plus 0 by 2. That means Q by 2 over A and Q by 2 over C. So that means half charge will remain here. Similarly, between C and D, half charge will remain at this one. Now it will consist of half charge, and now B will be remains and of half charge. and now they are bringing to closer to by 5 centimeter to each other. Now we have to find out the net force between them. So now first of all, let us calculate the force between A and B at the initial stage. So we know that F is equal to K Q square upon distance is 10 centimeter 10 whole square. So that is the force initially. Now net the force after the C and D has been contracted. So the net second force, that will be equal to K Q square by 4 into 5 whole square. 5 whole square means K Q square by 100. So first it was K Q square by 100, and next it was K square by 100. Um, K Q square by 100. Um, so that means F1 is equal to F1 and F2. So they are being uh, calculated, and the values are comes out to be equal to same. So that means in this problem the charge, whatever the force has been calculated, so initially before touching the conductor and after touching the conductor, and they brought close together by 5 centimeter, the net force comes out to be remain to be same. So that is kq square by 100. Here it is kq square by 100. That is by the calculation which we have shown it out. That was the one of the problem. Now next problem is two charges 4 microcoulomb and 1 microcoulomb are separated by 2 meter in air. Find out the point on the line joining the charges at which net force on the system is 0. Net force on the system is 0. We have to find out. Let us say they are being separated by distance of separated by 2 meter. Now at which point the net force is 0. So that we have to see. Net force at what point is 0? What point is 0? Is 0. So that we can able to find it out. So that we know, let us say we again redraw the diagram. 4 microcoulomb charge and 1 microcoulomb charge. So that means positive charge will exert a force over here, so this will exert a force over here. So some particular charge is going to be there which should be placed so that the net force on them will be 0. Let us say consider a point P. Now let us say total distance was 2 meter. Now let us say it is at a distance of x meter from here, and it will be 2 minus x meter from here. Now we know that two charges, they are going to repel each other at vertical point. When the force is being opposite to each other, they cancel the effect and the net force between them is 0. So if the charge has been opposite, so what would happen? Let us say it has a positive charge, it is a negative charge. So what would happen? It will be negative effect will be there. So there will be, so the effect, so this point, this charge should be here somewhere, because depended upon the opposite charges. So at this point the net force will be going to be 0, because this is going to for the charge, it is going to attract the charge, so the net force between them will be 0. But that depends upon the magnitude of the charge. If this magnitude is larger, this value is smaller, then the point should be here. But if the value is smaller, this value is larger, then the point should be here. But if they are of the same charges, the point should be anywhere depending on the magnitude of the charge. If the magnitude is larger, then it will be closer to this one, and if it is smaller, then it is closer to this one. Now this force is being calculated. F is equal to K. Let us say it is a negative charge is going to be there. So K into 4 into minus Q upon x square, and second force will be equal to K into Q into 1 10 raised to minus 6, 4 into 10 raised to minus 6 upon 2 minus x whole square. Now we are going to compare it out because equal and opposite forces are being acting. So we will get K minus 4 KQ upon x square is equal to minus KQ upon 2 minus x whole square. So into 10 raised to minus 6 will be also there, into 10 raised to minus 6 will be there. So that will be cancel each other, minus k will be cancelled. So 2 minus x upon x whole square is equal to 1 by 4, or 2 minus x upon x is equal to 1 upon 2, or 4 minus 2x is equal to x, or 4 is equal to 3x, or x is equal to 4 by 3 meter. So that means it should be at 4 by 3 meter from the 4 microcoulomb charge. So that is a point which we have calculated it out, 4.3 meter. So that's how we can able to solve this question.